Welcome to the Know and Go series. Have you ever really looked at a honeycomb? I mean, really looked close. It's not just some pretty pattern, right? It is an absolute masterpiece of engineering. And today, we're going to dive into a mystery that's literally been around for over 2,000 years to figure out how they do it.
So here's the big question, the one that's stumped people for ages. Why hexagons? I mean, why did bees always build these perfect hexagons? Not just kind of sorta six-sided shapes, but perfect ones with equal sides. Think about it. They could use squares, they could use triangles, but nope, it is always hexagons. So why?
And we are definitely not the first people to ask this question. Not by a long shot. This mystery goes way, way back. In fact, it's so famous, it even has its own name, the honeybee conjecture.
Okay, get this. All the way back in 36 BC, a Roman scholar, this guy Marcus Terentius Varro, he had a hunch. He looked at the honeycomb and thought, maybe there's a reason for this, a hidden logic. He guessed that maybe, just maybe, hexagons were the best shape for holding the most honey while using the least amount of wax. It was just a guess, right? A conjecture. But that one little idea kicked off a mathematical quest that would last for more than 2,000 years.
All right, so to really get why hexagons are the champions, let's do a little process of elimination. We'll start by looking at all of the other shapes and figuring out why they just don't work. Let's rule out the obvious non-starters first.
So first up, what if the bees just went wild and built random squiggly shapes? Can you just picture that? Every single cell would have to be custom built to fit perfectly against its neighbor. It'd be like a crazy jigsaw puzzle where you're inventing the pieces as you go. A total logistical nightmare.
And yeah, you can see the problem with that right away. It would basically force the bees to work one by one. You'd have a whole bunch of bees just sitting around waiting for their turn. But that is not how a beehive operates. They are all about teamwork, a collective workforce where everyone is building at the same time. And to do that, you need uniform, identical parts. So yeah, squiggles are definitely out.
Okay, so we've established we need uniform shapes. Well, what about something like a circle? That seems pretty efficient, right? Or hey, maybe pentagons or octagons. The big problem, though, is that none of these shapes fit together perfectly. If you try to pack them side by side, you always end up with these annoying little gaps in between.
And those gaps, they are a massive problem. A deal breaker, really, because every little gap is wasted space. The bees would have to fill it in with extra wax, and that means wasted material and wasted energy. So the key here, the absolute non-negotiable, is we need a shape that fits together perfectly with zero gaps, something that creates a super tight, secure structure. That's how you maximize efficiency.
All right, so we need a uniform shape that can cover a surface with no gaps. Now this is where it gets really interesting. It turns out, good old mathematics tells us that there are only 3 regular shapes that can actually do this. Just 3. So that narrows our search down to our final contenders.
Contender number 1, the equilateral triangle. 3 equal sides, they lock together perfectly. Yep, this is a definite possibility.
Contender number 2, the square. You know this one. 4 equal sides makes that classic grid pattern, absolutely no gaps. Another very strong candidate.
And finally, contender number 3, the one the bees seem to love, the hexagon. 6 equal sides, and yep, we know for a fact they tile perfectly. So, this is it, the big showdown. It has to be one of these 3 shapes.
Okay, so if all 3 of these shapes work perfectly without gaps, how do the bees choose? What's the tiebreaker? Well, the answer comes down to one single, incredibly critical resource, wax. See, bees are obsessed with efficiency, and for them, wax is like gold. It is unbelievably expensive for them to make.
And this brings us right back to that Roman scholar, Varro, and his original guess. The challenge, the whole game, is to find the shape that has the smallest possible perimeter. Let's break that down. In bee speak, it means which shape can hold the most honey while using the least amount of wax to build the walls. That right there is the ultimate efficiency test.
So just how expensive is wax? Are you ready for this? To make just 1 ounce of wax, a bee has to eat about 8 ounces of honey. That is a crazy expensive conversion rate. Imagine if your building materials cost 8 times their weight in food. You would not waste a single speck. You would design the most ridiculously efficient structure you possibly could.
So, let's recap. The bees had the motive, efficiency. Varro had the hunch, hexagons. But for 2,000 years, that's all it was. A really, really good guess. It wasn't until modern mathematics came along that we could finally, once and for all, prove it.
I mean, just let this sink in. The question was first asked in 36 BC. The answer wasn't mathematically proven until 1999. That's a 2,035-year wait. That's when a mathematician, Thomas Hales, finally cracked it and gave us the definitive proof.
And the winner, after more than 2 millennia, is the hexagon. Big surprise, right? Hales' proof laid it all out. Of our 3 contenders, the triangle, the square, and the hexagon, it's the hexagon that has the shortest perimeter for the same amount of area. It is, without a doubt, the most efficient shape, period. That Roman guy, Varro, he absolutely nailed it.
You know, even the great Charles Darwin was blown away by this. He called the honeycomb absolutely perfect in economizing labor and wax. And that's exactly what it is, a masterpiece of natural engineering, fine-tuned by evolution to be as perfect as mathematics will allow. The bees, well, they've known this secret all along, haven't they?
It really makes you wonder, doesn't it? The perfect solution to a really complex math problem has been buzzing right over our heads in beehives for millions of years. So I'll leave you with this thought. What other amazing, elegant solutions, these natural masterpieces, are hiding right out there in plain sight? Thank you for listening to this Know and Go episode.